So scary? Why do we issue warnings about them? Why do we want to learn about them? And why do we name them? Well, that's what we're going to talk about in today's lecture. So today's lecture covers the hazards posed by hurricanes and also discusses a little bit about why we name them, how we name them. I will, for the third time, drill in the idea of the difference between a hurricane and a typhoon. And so that's what we're going to be talking about today. So the goals for this lecture are first to explore the main hazards of hurricanes and tropical cyclones. Then we're going to talk about the difference between a hurricane and a typhoon, why we name them, how we name them, and then we're going to discuss some notable hurricane events. So hurricanes like Katrina or the 2017 outbreak, Harvey, Irma, Maria. What was happening there? All right, so first, hurricanes actually are not a one-trick pony. They actually have numerous hazards that they pose to residents. And here there are actually 4 particular hazards: wind damage, flooding, storm surge, and tornadoes. And here's what each of these act like. So first off, wind damage. Hurricanes have very strong winds. And even if you're not in the eye wall, which is where the strongest winds are located, you could still experience very catastrophic winds that are capable of ripping tiles off of roofs, ripping roofs off of houses, hurling debris into windows, flipping over cars, causing all kinds of tremendous damage. And then flooding. So hurricanes are also huge engines of heat and moisture. This means there's a lot of rainfall that can be produced by hurricanes. And what's actually interesting is Houston, I actually am recording this lecture after Hurricane Harvey happened. And what I actually have down here for Tropical Storm Allison, Tropical Storm Allison flooded Houston with over 38 inches of rain in a 6-day time period. Well, Hurricane Harvey actually bested that. There were some regions of Houston that received over 50 inches of rain in a 6-day time period, in a very short time period. Just to provide you with a little context, here in California, where I'm recording this lecture at, we receive on average around 14 inches of rain here in San Jose, California. Again, that's where I'm at right now. So more than 3 times our average annual rainfall in one storm. And this usually happens when the storms are very slow moving, meaning they hang out over the same area for the same period of time. The next big thing is storm surge. This is actually the deadliest element of tropical systems. And the reason why is because those winds, not only are they causing tremendous amounts of waves, but they also have an extra tool up their sleeve called Ekman transport. And Ekman transport actually causes the water in the ocean to bulge upward, kind of like a tide. And so when a hurricane is coming on shore, not only are you getting waves, but the sea level itself is rising due to these winds. And then finally, tornadoes. Believe it or not, tornadoes can actually form inside hurricanes. So let's talk about this. So first off, wind damage. This is just an example of just some wind damage caused by hurricanes. If you take a look here, you have a gas station shelter completely blown over by a hurricane. These are relatively weak structures, so a Category 1 or Category 2 hurricane at its most intense may be able to do this. This is probably more likely caused by a Category 3 hurricane. And then if you take a look over here, this image shows tiles and actually parts of a roof being ripped off. Again, wind damage is really relative inside the hurricane. On the outer fringes of the hurricane, winds are relatively weak, and again, it could just be a windy, blustery day. The closer in you go towards the eye wall, the winds become stronger and stronger. In the case of a Category 3, 4, or 5 hurricane, you have wind speeds that are the equivalent of some major tornadoes. So the wind speeds can actually get very intense and cause this kind of damage. This is a picture of Houston taken after Tropical Storm Allison. Tropical Storm Allison was over a decade ago. In fact, as I mentioned, Hurricane Harvey just last year or several years ago, depending on when you're watching this. I'm recording this in 2018. Hurricane Harvey actually caused much, much more damage. And you saw very similar scenes to this. As I also mentioned, tornadoes can form from hurricanes, and the reason why this happens is once a hurricane hits land, it begins to experience the feeling of friction near the surface of the earth. However, higher up, the winds are still blowing very strong. This creates a type of wind shear called speed shear. And what this causes rotation to begin to occur. Rotation can then create tornadoes, just like we talked about in our last module. Rotation can create tornadoes. But the deadliest of all hazards posed by hurricanes is storm surge. And the reason why storm surge is so dangerous isn't just because of the waves that the wind is producing, but again, you get this large bulge of water that builds up as a hurricane is approaching due to those really fast winds. So basically it's like one gigantic, extremely long bulge of water coming on shore. And that's in addition to the really high waves. So in a very real sense, you can get tremendous amounts of sea level rise and tremendous amounts of damage caused by storm surge. And that's what makes storm surge the deadliest hazard posed by hurricanes, because it's one of the most destructive. This is one of the reasons why even in minimal hurricanes, they'll usually try to get people away from the ocean. Now, what's in a name? So we've discerned the idea that, okay, we want to issue warnings for these storms. We also want to be prepared for the hazards that they cause, but why do we name them? Well, the idea behind naming a hurricane comes from the fact that more than one of these storms can be present around the world at the same time. And in fact, I'll show you in an image in a few minutes that you can have multiple hurricanes during one period of time. And so when you're watching the news and somebody says, hey, a hurricane is approaching, well, you would probably want to know which hurricane is approaching you. So we use names to allow us to differentiate one storm from another. And we use names because it's a little bit more approachable. It's a little bit more easy for people to remember a name than a number like 12L or 15 or so that's why we give these hurricanes names. The names are actually internationally agreed upon. And the purpose of this is to prevent confusion. Imagine if there was a hurricane coming towards the United States, but it was also going to affect Puerto Rico, Cuba, the Dominican Republic, and Haiti, and there's even a chance that it could affect the Yucatan Peninsula of Mexico. That's where Cancun is. And imagine if each one of those countries were to give the hurricane their own name. Well, that would create a lot of confusion because Mexico would be calling it one thing, the Dominican Republic would be calling it another, Cuba would be calling it another, the United States would be calling it something else, and so on and so forth. And so this would create a lot of confusion. So in order to alleviate this confusion, these names are internationally agreed upon. So Mexico, Cuba, the Dominican Republic, Puerto Rico, all of these areas in the impacted region agree we're going to call the hurricane the same thing. Here in the northern hemisphere, we track these hurricanes and then we name them based on their intensity. And here in the northern hemisphere, we name them, and so here in the northern hemisphere, these hurricanes are named by the laboratory that's tracking them. Here in the Atlantic and the Eastern Pacific, where we live at, these hurricanes are named by the U.S. National Hurricane Center. Out in the Central Pacific, that's where Hawaii is, any storms that develop out there are named by the Central Pacific Hurricane Center. There are hardly any storms that actually develop there. Most storms that hit that region form in the Eastern Pacific. And then to prevent confusion, if a storm forms, it keeps that name for the rest of its life. Until it dissipates, it has that name. So, and again, that's to prevent confusion as well. Now, with that said, coming up with names would be very difficult to do. It's like when I come up with multiple choice questions for a test. It's hard to come up with an infinite number of questions that are worded the right way, and I'm sure many of you feel like maybe not all my questions are worded the best. There's only a finite number of names out there. So rather than coming up with a brand new list every single year, the National Hurricane Center actually recycles names. It recycles it, and it recycles these names. So, for example, there was a list in 2015 that started with Anna, Bill, Claudette, Danny, Erica, Fred, Grace, Henry, and so on. And usually the way these lists work is they alternate from male to female. So female, male, and so on. So they alternate genders, and then they go in an A, B, C, so they go in alphabetical order. Well, rather than coming up with a new list every single year, what will actually happen is in 6 years, so in 2021, this same list will be used over. And then in 2016, the same thing happened. In 2017, the same thing happened, and so on. Now, with that said, think about some of the most catastrophic hurricanes ever. Think about Hurricane Maria, or think about Hurricane Harvey, or think about Hurricane Irma. Those names end up developing a reputation with them. And so what will actually happen is after a particularly catastrophic storm, they will no longer use that name. They will retire that name. So for example, Harvey, Irma, and Maria will never be used again simply because those names will always be associated with that particular storm. So Harvey will always be known as the storm that devastated Houston. Maria will always be known as the storm that devastated Puerto Rico. So Irma will always be known as the storm that devastated Barbuda. So they will always be associated with that particular storm. And so we don't want people to then hear Harvey 6 years from now, oh my gosh, Harvey's back. So we retire the name. So if you notice on this list, nowhere on this list is a Katrina. Nowhere on this list is Katrina. Instead, it was actually replaced with the name Katia. And then if Katia ends up becoming an intense hurricane, causing damage, and ends up getting retired, they would then replace it with a new name. And with that said, what about the difference between a hurricane and a typhoon? This is a common question that I get when I talk about hurricanes, and the answer is actually very simple. Absolutely nothing. I have two storms here. So this is Hurricane Irma from 2017. Over here, this is Typhoon Haima. If I'm mispronouncing that, please forgive me. And this was actually about to hit the Philippines. If you take a look, they both have very similar structures. They both have eyes in the center. They both have spiral rain bands. They both have beautiful outflow. They both look like buzzsaws. Well, there's really nothing different between a hurricane and a typhoon. They're both tropical storms. They both are both tropical cyclones. They both can develop eyes. They both have lots of rain. Everything about them is the same, with the exception of where they form. So, what does that actually mean? Well, here in the Western Hemisphere, everywhere here in the Western Hemisphere, so that is west of the west of the prime meridian. That's that line right here. Everywhere west of here, we call our tropical storms or tropical cyclones, we call them hurricanes. In the Western Hemisphere, here in the Western Pacific, particularly north of the equator, they call their storms typhoons. And then down here in the Indian Ocean as well as the Southern Atlantic Ocean, the storms that form down here are called cyclones. But they're all the same thing. The only difference is location. So I mentioned previously that when a storm forms, it gets a name, and if that storm wasn't anything particularly remarkable, once it loses that name, the name is reused 6 years later. Well, this is Tropical Storm Katrina from 1999. It was a very weak tropical storm. It hit Central America. It caused very little damage, very little anything. It was just basically a rainy day. And so nothing remarkable was associated with the name Katrina in 1999. Well, 6 years later, when this storm name was reused, it was assigned to the most devastating hurricane in United States history. Hurricane Katrina, the most devastating hurricane in United States history. Harvey rivaled this, not so much in the the amount of deaths that it caused, but more so in the amount of damage that it caused. But Hurricane Katrina will always go down in history as one of the most devastating hurricanes in U.S. history. It struck the eastern part of Louisiana, barely missing New Orleans, on August 29, 2005. The day before, it had maximum sustained winds of 175 miles per hour, putting it in Category 5 status. When it made landfall, its winds had weakened a little bit. It was undergoing what's called an eyewall replacement cycle, and that caused its winds to weaken a little bit to 125 miles per hour. Its total damage in 2005 dollars, so this would be higher in today's dollars, was $108 billion in damage. Think about that. If you actually put that in 2017 dollars, that's even more than Jeff Bezos, the owner of Amazon, actually is worth. So that's a lot of money. But what was most devastating was it caused 1,700 deaths here in the United States, most of them in New Orleans. The name was retired. It'll never be used again. When people think about Katrina, they don't think about that little tropical storm from 1999. No, they think about Hurricane Katrina. They think about the most devastating hurricane in U.S. history. Now, that wasn't the only storm that caused a lot of damage. Some other previously notable storms, Hurricane Ivan, Hurricane Charlie, Hurricane Andrew, Hurricane Hugo. These are actually all historically intense, very damaging storms. And yet, if you combine these storms, all which had very similar intensities, they actually still totaled less than Katrina. Well, why was that? Well, it was because Katrina hit a particularly vulnerable location. Not so much because it was an exceptionally strong storm, though it was at its peak. It's because of where it hit. New Orleans. If you know anything about the geography of New Orleans is below sea level. So it's basically a bowl surrounded by water. Well, when a hurricane comes on shore, it raises storm surge, or it raises those sea levels. So that put a lot of stress on the dams and levees that were in New Orleans. Eventually, many of them failed, and boom, the whole city flooded. And it was pretty sudden. And Hurricane Katrina's track changed over a few days. It was expected initially to hit the Florida Panhandle, but then it hit New Orleans instead. So that caught people off guard. It was a wake-up call for us here in the United States. Now, the last thing I'll talk about with this particular lecture was the 2017 hurricane season. So I'm actually giving this lecture after this season occurred. The 2017 hurricane season in the Atlantic Ocean was extremely active. It was actually the 5th most active season on record. What that means is that it produced the 5th largest number of named storms, so storms that reached at least tropical storm status, and it created a lot of hurricanes and major hurricanes. The totals were 17 named storms, 10 hurricanes, 6 major hurricanes. Now this is very impressive right here because most years only give us 1 to 2 major hurricanes. This year we had 6. 2017 produced 6 major hurricanes. The most notable hurricanes, Hurricane Harvey, which produced tremendous amounts of damage along Houston. Hurricane Irma, which, as I mentioned earlier, devastated Barbuda. That's one of the islands in the Caribbean, and was actually one of the strongest hurricanes in Atlantic record. It had wind speeds at one point of above 185 miles per hour. And then Hurricane Maria, forgive me. This devastated Puerto Rico as a Category 5 hurricane. So these were some pretty devastating hurricanes. And they all happened one right after another. Now here's an image showing 3 hurricanes happening one right after another. This was taken all at the same time. The hurricane here to the farthest left, this was Hurricane Katia. So this got the same slot that Katrina had. It was Katrina's replacement name. So that's why they didn't name this Katrina, because then people would have thought, oh my gosh, Katrina's back. This was Hurricane Katia, and this actually hit Mexico, and it didn't cause a tremendous amount of damage. This right here was Hurricane Maria, one of the strongest hurricanes on record. And if you take a look, it's a particularly large storm. And this was it. It had just passed the Dominican Republic. It's between there and Cuba right now. It eventually went on to hit the Florida Keys and cause a lot of damage in Florida. And then back here was a developing and quickly intensifying Hurricane Maria. These all happened one right after the other. But why? Why did this happen? A lot of people, they hear this and they go, oh my gosh, climate change, or what's happening? Well, it's very likely that as you're listening to this message, or as you're listening to this lecture, we might be in a pretty inactive hurricane season. Well, what happened during this time is the conditions for these storms to develop were just right. The Atlantic Ocean was much warmer than average, so there's lots of warm water, and there was just no wind shear. So the storms were able to not just grow, but intensify easily. And so that's why this happened. But it doesn't always happen that way. Some years there's a lot of wind shear over the Atlantic, and so storms can't form. Other years, the waters are too cold, or other years, there's more mid-latitude cyclone activity. And actually, the next lecture, we're going to talk a little bit about what are called superstorms and how hurricanes may play a role in them. And we're also going to talk a little bit about if climate change